Hello, everybody. We are Group 7. We're doing the ABC competition, Autonomous Vehicle Challenge. My name is Zach Hogan. Other group members are Corinne Robertson, Skylar Tyler, Andrew Perez, Justin Breeze, and with me today, Michael Lindy. So one of the big things we're trying to incorporate into the project management for this is the Jira software. It is kind of difficult to get going, but once you do get it going, it does help things quite a bit. For instance, it'll break down the to-dos in progress and issues done. So what we did initially is we broke down all of the report requirements and tasks that we think need to get completed for this project week by week into what are called sprints, and assign those to individual people based on our approach that we thought would work good for this project. And so with that, you can see the different weeks are now sprints, and that's located in our backlog. You can see there's a lot of issues that we're trying to tackle right away, as many as we can, really pushing ourselves up front so we don't have to mess around with those breaks later in the semester. And eventually we'll have a presentation week where we're just trying to practice the presentation and hone in our good presentation for the finals week. Michael and I have been the people that have been taking in the reporting from the different team members of their when they report on their different responsibilities throughout the weeks. And we try and keep an eye on the overall formatting as we bring that information over, the citation style, and just making sure that that report is getting done as well as possible to eliminate some of that work that we'd have to deal with this down the road. So we did a little bit of calculations for turning. We think we're going to definitely need to revisit this one, but this was some of the work done this week. So what we are trying to figure out here is, how fast do each of the wheels need to turn in order to make our turns in this competition. We're going to have 4 90-degree turns and then another turn in the opposite direction. That's not quite 90 degrees, or it would be a little over 90 degrees, excuse me. Anyway, we have some calculations here where we wanted to figure out the difference in the motor speeds. If you wanted to take, say, a certain degree turn over a certain amount of time, so that might affect, how fast are those going. We want to incorporate a radius to that turn later, and then do some tests with that as we start to integrate and assemble this thing. So like I said, we'll have to revisit this, but this is a little bit of the work that we've done this week. And what we decided to do was to use 2 Arduinos to have a sort of the master slave setup. The first Arduino is going to have the controls sensor data, and it'll do a lot of the calculating and route planning, and we'll send minimal information over to the second Arduino, which will be the slave that controls movement of the robot. All that will be done in C++ programming language.
And we originally were going with the motors that were provided, but we found that the torque that they provided wasn't quite sufficient, and they didn't have a high enough top speed. So this one here provides a nice almost 10 miles an hour top speed, which allows us to finish the course in about, if we were running at top speed, in about 25 seconds-ish, and it provides enough torque to get up that ramp easily. This is a rough 3D model of the chassis. As you can kind of see these dimensions on the side. We're hoping to get this finished up in the near future so that we can have a good model for it and we can start building it, probably with 3D printing it, so it's nice and light. This is the block diagram for the bot. The inputs will be the GPS, the compass, the power, and the distance we want to go. And then it'll output the voltage to go at that certain speed and distance. And then we'll get some feedback on that to make sure it's going at the proper speed. It'll be the encoders. And those will feed back into either increase or decrease the voltage to get that desired speed. And this is kind of the flow chart of it. It'll get the initial location, and then it'll get the initial bearing, and then it'll plan the route. That's the setup. And then for the loop, we'll have it start. It'll start moving towards the waypoint. If it's off course, then it'll use like a PID controller to move back onto course. It'll update its location and bearing, and then it'll continue this loop again. Does anyone have any questions? And thank you for listening.